I would like to welcome you to Orchard Park, home of Team 2056. If you have any questions about today or like where anything is, I can help you with that. I would like introduce Shah and Malavya to do FRC strategic design and how to decide your robot design.
Okay. Hi everyone. We can just click on that. So my name is Malavya. I've been part of FRC for 13 years now, 10 years as a mentor, and this is my 11th season. So one of the things I wanted to mention is I graduated from University of Waterloo for mechanical engineering, and I've been the lead design mentor for 1241 for the past 8 years or so. I was a student from 2007 to 2009, and right now I work as a mechanical specialist engineer at Gypsum Technologies. They make big machines that make drywall and smoke boards, so I designed those machines.
Hey everyone, my name is Shaqeeb Momen. I'm currently a student at McMaster University doing mechatronics engineering and management. I joined FRC back in 2014 in my freshman year of high school, and I've been a part of FRC for about 6 years now. I am doing a co-op term working under Malavya, also at Gypsum Technologies, so I helped him with designing of big machines that move rectangles.
So a couple of objectives today. We're going to learn about the importance of strategic design. So what that means is essentially you're trying to decide what your robot wants to do before you build it and try to experiment. So it's a really important task to keep you guys focused in terms of the build season. I know bag rules have changed, so you don't actually have the 6-week deadline, but it really helps you keep on schedule if you know exactly what your robot has to achieve. We're going to go over some kickoff items that how 1241 and 1285 does it. So we actually have 2 teams at our school. One is a junior team, one is a senior team, and we run them together, and it's like 2 teams working out of the same facility. And then we'll go over some game analysis, so key things to watch out for inside a game. Some strategic mechanism selection, so how to pick whether you want an elevator or an arm or things like that, depending on your capabilities. And some winning designs in the past, and we're also going to spend about 45 minutes doing a mock kickoff for an older game. So we'll actually go through the whole session, and then I'll divide you guys up into groups so that you guys can pick and choose what your robot would do for that particular game. And we'll spend 45 minutes doing that.
So some general tips are, there is no right answer in a FRC game, as with most things in engineering. There's only a answer that meets your goals and requirements. So if you're here for Holton's presentation, he emphasized the idea of making sure you know your goals ahead of time. Same thing here. Whatever design you choose to go with, if you are careful, conservative, and smart about it, for the most part, you'll get to where you want to be. And another piece of advice around that, and you'll hear this a lot from every engineer who's experienced in what they do, keep things as simple as possible. It just makes things easier across the entire spectrum. Pay attention to the orientations of your game piece. Sometimes in games in first, where they start will be different than where you have to place them. Sometimes they won't always be in the same orientation at different locations in the field. So if you're considering the idea of possession, understand that if your mechanism may need to adapt depending on the orientation of the object. And this applies to mainly things that aren't balls. Also, another thing, this is very important. It's fairly straightforward, but you definitely keep your eye on it. Possessing game pieces as quickly and easy as possible. On Team 1245 and 1241, we just call this touch and go. The idea is as soon as your driver or the mechanism or what touches it, you now have possession of it. The biggest thing that you notice when you analyze a team and determine how good they are, a lot of times is how well or how quickly they can possess a game piece. If someone is struggling to possess a game piece, you'll notice it immediately. Whereas if someone's capable of grabbing a game piece quickly, it's sort of overlooked, but because it's so fundamental to playing a game well. The other thing is try to take load off your motors whenever possible. Motors don't like to be under load all the time, and it ends up drawing current and causes a whole lot of issues. So if you look at mechanisms, and you'll definitely see a lot of them on 2056's robots out in the hall in here, is that they'll have things like springs, surgery tubing, and other things that apply constant load, so that when the motor doesn't have to work as hard to move the mechanism and the stuff we're doing. As a rule of thumb for us, when we're doing something like elevator, we counterweight it so that the motor lifting just the mechanism itself is weightless, and it only has to do with the actual weight of the game object, which tend to be pretty light. Another thing, sensors, use them as often as you can, because anything you can take off the driver's mind is going to increase your performance, because clearly the robot brains are better than our brains. Another thing is always prove your designs through prototyping, not necessarily assumptions, unless it's something you tested, tried and true in the previous. So if it's something new, always go through the prototyping process first. If, let's say you're redoing a mechanism, let's say you've done a shooter in the past and you've done the prototyping process, maybe you don't need a prototype to make sure it works, but more so for the idea of geometry. On our team, you'll notice that we tend to stick with the same general design choices. When we prototype, we're mainly looking for specific geometric or numerical requirements for our system, not so what system to choose. And then the biggest and probably most important thing, besides being simple, is pay attention to your resources. Always stay within them, because the biggest thing that probably gets teams is they overestimate what they can do, and they don't really realize the resources handed them, or sometimes they're relying on maybe getting a sponsor that doesn't exist for them right now, and it bites them in the butt later.
Okay, so your fate lies in the kickoff. Essentially, your kickoff weekend and stuff like that, this is something that might be accelerated for a lot of teams. But what we like to do is within the first weekend, we actually know exactly what our robot's gonna do and what mechanisms are on it. So within the first 2 days, 1241 and 1285 decide pretty much what their robot's kind of gonna look like. The only thing that we have to verify is dimensions of the mechanisms through prototyping. So for example, if we know that we're gonna do a wheeled intake and we're gonna be able to go to the level 3 of the rocket, we've already decided that's what the robot's gonna do. And what we have to do is determine how to intake the ball or how to grab a disc from the feeder station and things like that. So we try to keep it really quick. The reason being is because most top teams try to finish their robot within 4 weeks rather than the 6-week schedule, so that they have 2 weeks of practice or autonomous development before they bag the robot. Now this year rules are changed, so you don't have to bag your robot, and you might have a lot more time before your first event, but it's still good to have your robot done within the first 5 weeks, for example, if you have an extra week. This way you can spend 2 weeks of driver practice or even development of the autonomous routine. So one thing to keep in mind with the new rule changes, pretty much everyone's game should be elevated this year, just by a factor, for example. So first week regionals may not be easy because teams have already had so much time to practice with their actual real robot. So keep that in mind, that you want to try to be as quick as possible with your decisions. And remember, if there's no right answer, you can still optimize it to be the best it can be. In several games, you'll have different types of robots that are as successful or more successful, depending on if it is. Like for last year's game, Cheesy Poofs made a single jointed arm on an elevator on a turret on a drive chassis, and 2056 made a simple one jointed arm on an elevator. Both performed the same way, but it's 2 different approaches to the game in terms of success. The things to also decide during kickoff is what your drive chassis would be, your strategic capabilities, so what you want your robot to do, and also the mechanisms that you want to prototype. So what we like to do is spend an entire week of prototyping. Some top teams don't do that. Like 2056 actually doesn't spend as much time prototyping because they have references for past designs that they like to reuse. So this robot here is from 2018, and this one's from 2019. They actually look very similar to each other, and so it's nice to reuse past designs if you know that they're successful. There might be little tweaks here and there, but it allows them to finish their robots faster as well by reusing previous designs that you know work. On 1241, we like to do that for our drive chassis. A lot of the concepts are the same from different years. The only thing we adjust is if we have to go onto a platform or not. Yeah, so kickoff is really important because that will determine everything that we need to do for the rest of the season.
something that is a little different about our team is, for the sake of packaging, because that tends to be the biggest trouble to deal with when we're putting all our mechanisms together. So we prototype a full wooden robot. Hopefully you can see that image in the left over there. You're right. We prototype the whole robot not necessarily for like the performance of it, like it doesn't drive around, we kind of move by hand, but just to make sure everything fits in the way we expect it to. Because when we do our strategic development as experienced teams, sometimes we do a lot, and the thing that limits us is not our ability to design individual systems, but our ability to put them all together. Okay, so getting into our kickoff schedule, the Saturday at 9:30, we gather to watch the game. Generally speaking, we do this as a big group. More recently, we started inviting other teams to watch the reveal with us, and we just projected it at our school. After we see the game, or the game stream, we go to lunch, and then we sort of just begin reading the manual as like a pre-scan. Then afterwards, we sort of do a detailed reading where we split into groups of 4 to 5, just to keep discussions easy and clean, with mentors. And we make sure to read the game manual thoroughly, read every single section, and write down any questions that we have, or particular notes that we've discussed in the group. Because once we're done, we come all together, and any question that groups have had, we bring them up as a whole group and see if we can figure out, or if this is something we want to bring to Q&A afterwards.
So this process takes about 3 hours or so. You can go to the next slide. For reading the game manual. So like all the way from 11 o'clock till the reveal is done, till 4 o'clock, we're just reading. And this way it allows us to actually recognize little things on the game that might be ruling out different strategies that you can't do. Like last year, if you pick up 2 balls at once, you get a penalty. So we wouldn't design something that could pick up 2 balls and that kind of thing, right? So you have to watch out for these kind of little roles in games, and also figure out your robot dimensions by seeing the maximum sizes. Last year, I think there was a perimeter constraint in terms of how big your robot is, but in previous years, like 2017, you actually had to fit within a volume, including the bumpers. So these kind of things can change from year to year. Last year, they also increased the weight limit to 125 because they forced you to put a compressor on the robot, and you can't do off-board compressing. So those are the kind of things to watch out for, and they're little details that will help you along the way throughout your season. After 4 o'clock, essentially we figure out what the robot needs to do. This is not the mechanisms that it'll use to do it, it's actually what your robot's gonna do. Whether it's gonna climb onto the level 3 platform, which height of the rocket are you gonna score in? Are you gonna score the balls and the hatches? Are you gonna score only the balls? Exactly every movement that the robot wants to do. And what we do is we separate those movements into the different subsystems of a robot. So which includes the drivetrain, the intake, the tool or elevator or any sort of lifting mechanism, and also the end game. So what happens is on the Sunday, when we go on to that, if you want to go to the next slide, is essentially we're actually targeting our mechanisms and our brainstorming sessions exactly to accomplish the things that we said the robot will do. So if the intake needs to pick up the balls and the hatches, the prototypes or the mechanisms that we discuss on the Sunday have to achieve that. If they don't, then they're actually ruled out really quickly. So this keeps a more focused discussion by knowing exactly what your robot needs to do, so that when you decide how to do it, you know exactly what you need to accomplish. So this is very important for the first 2 days. Essentially, you have to decide what your robot needs to do and what you will use to achieve those goals. This is just a 2-day timeline. Obviously, for different teams, it could take longer to come to a decision. But one of the most important things that we do on 1241 is that everybody agrees to that decision. And so it's called a consensus, not a vote. So we don't do majority wins. We actually figure out the pros and cons and actually decide together. And one example we had in 2018 was that we wanted to do a particular type of hanger to climb up the bar. There was one student against 23 in terms of that decision, and in the end, the 23 students were convinced to go to what the one student wanted. right? So it's nice to actually have your entire team believe that your robot is exactly what you want to do, because that's important to make sure that the 6 weeks that follow, everybody's kind of on the same page. Yeah. That actually covers lunch or Sunday, for example, where essentially in the morning we discuss the different designs, we brainstorm for a few hours and stuff like that. And then in the afternoon, we decide which ones we want to go with. Generally, for each category of your robot, we pick 1 or 2 that we want to prototype in the future. So this way, we do keep our options open, and based on the prototyping, we can choose the mechanism that we'd like to go with. And your prototyping will essentially determine dimensions of what the mechanism does. And that kind of takes care of Sunday.
Yeah, another thing to mention is that in between that process, we like to make sure we introduce all the mentors and where our specialties lie, just because this is sort of the one day we have all our new students around us at once, and all the mentors manage to come out too, because notably in other days, people sort of come and choose whatever days are free. It's good to give our new students a sort of introduction as the people that will be helping them and will be working with for the season, just to break the ice a little bit. Oh, one more thing to note is that by this point in time, end of Sunday, we've discussed what kind of drivetrain we want. And you'll see this with a lot of top teams. They like to pick their drivetrain quickly, not make too many crazy decisions with it, and begin analysis and designs of it right away. You talk about parametrics?
I think we're good.
Yeah.
Okay, all of our information of what we'll cover today and what we actually do in the entire 6 weeks of season is published in our playbook, is what we call it. And that's available on our website. So you can download it. We adjust it from year to year and add design tips that you can watch out for. So it actually covers every single day of our entire build season in terms of what we need to accomplish. So it's really detailed, and I think it's like 14, 15 pages or something like that, but at least it's a guide for you guys to see how we come about our decisions and what we do during the 6 weeks.
Okay, so for reading the game manual, key notes are finding important loopholes, which is fairly obvious. They're kind of hard to think about. You sort of have to, and this is why we take so long to read them. If you read something once, you're generally not going to identify stuff like this immediately. You read it through again, things start to come into mind. Some examples would be in 2011, does that say 2011? Yeah, 2011, 11-14 is chokehold strategy, and then 2015, the idea that during that game, you had a starting configuration, but afterwards you could expand to whatever volume you'd like. So some teams back then, they decided to make 2 separate mechanisms. One would stay at a certain point in the field, and the other, via a wire, was just tethered while it was doing all the motions. So that way you sort of split the tasks. In some cases it was very successful, in other cases it wasn't that successful. But the point is to identify crazy things like that you can do. Another note is that important details, very small details, can define exactly how you choose to climb. For example, in 2017, you were offered the choice of using a default rope that the field would provide, or that FRC provided, or you could bring your own. This would mean that you could either, okay, let's design a mechanism around the standardization of the rope that they gave, and however specific or vague that may be, versus bring your own rope, which is you controlling more variables, and being able to climb that way. It actually allowed several types of climbing mechanisms. Some teams would use the knot they would tie at the end, and other teams didn't bring a rope, they brought a strip of Velcro, and those climbers are significantly more successful than people would have previously thought.
That's all good. Go with that.
Another thing is key details for drivers and coaches to understand for when they practice. So knowing what the human player can or can't do, what the drivers can or can't do, fairly obvious. Everyone should know these things, but your coaches and drivers or people involved in that area should read them through detail. The reason that everyone is supposed to know this is just so you can cross-check. It's always good to have a little bit of redundancy.
Yeah, I think in 2014, if you put your hands into the field while giving the big ball to the robot, you get a 50-point penalty, which is like a huge amount.
Yeah.
And then in 2017, I think if you reached out of the airship, you get a red card. So all of those things are really important in terms of knowing to watch out for when you guys are doing practice. Because not only do we practice with the robot, we also practice with our human player. So they have to watch out for these things too.
One more thing of note, back to the first point. FRC is trying to get better and better in terms of their game design, as to making sure crazy loopholes that guarantee you win don't exist anymore. So this definition of like loopholes or chokehold strategies changes a little bit. It's sort of more defining the situation at which you guarantee more points than your opponent, as opposed to guaranteeing a win. For example, before that, what you'll notice is that near the end of a season, so like week 6 or Worlds, all the teams sort of saturate in terms of the number of cycles they can perform. And then if you look at everyone's tally-up performance by alliance, the top set of alliances, competition to competition, generally speaking are all the same. So what ends up happening is, in past seasons as well, and this is mainly apparent in 2018, your tiebreakers in that respect come from any other thing you do in the game. So in 2017, by the end of the season, people were hitting 4 orders like it was a joke. People were hitting 4 orders like by half of the match. So what differentiated you was whether or not you were able to get a bonus at the beginning when you would get 40 KP in auto, or just like 1 or 2, 3 balls that you'd score during the tie-up period whenever you had time, or defense, of course. That's always the case. The other thing would have been in 2018, if you look at, since you would score cubes on a big scale, which is giant teeter-totter, and you only get points if you had it on your side and based off how long you had on your side for. So what would happen is, since everyone is scoring at the exact same rate, what would happen is the alliance would win depending on who had it after auto. So now all of a sudden you squeeze out that last bit of performance by optimizing your autonomous. And this can come in the smallest of details, such as in 2018, 1241 and 2056, they'd actually synchronize their autos. So as one robot was placing, the other robot was right and ready. So if you look at match views back then, they're sort of in sync, and it just happened to work out that way. And that way, if you can guarantee you have possession at the beginning, since you know that during tell-up, everyone's scoring at the same rate, you'll know you have it for the entire match, and therefore you have 2 minutes worth of points.
So this next one is just a brief understanding of how scoring breakdown works. This is something that's important in the game manual. There's usually a chart that tells you exactly how the points go. So it's really helpful to keep that chart available at all times. And then one of the things that we like to do is determine what you can score in autonomous, how the points work with that, versus tele-op, because sometimes there is a bonus for scoring more. And then the other thing is to determine a maximum score. Now this depends on whether you're able to get a full amount of game pieces or whether they get recycled during the game. So if they do get recycled, it's sort of hard to get a really maximum score. But what you can do is estimate how you think how long a cycle would take, and then just do a bit of multiplication to figure out your max score. The reason you want to know the resources or the maximum score is essentially you want to try to achieve a percentage of it that you think you can contribute rather than just like 1/3 of it in order to make your robot successful. It's very hard to determine what the ideal score would be in order to guarantee a match win, but you want to estimate for about half of the max score being done just by you. That's sort of like just a pointer to go off of. The other thing that you can do is also optimize the time and resources required to get a certain amount of points. So if it's a really complicated end game that you have to do, figure out whether you can score faster in tele-op to make up the same points as the end game, so then you can actually take away the end game from your robot. 1231 likes to do this a lot, because we believe that if we're faster at scoring during the gameplay, we don't need to do a complicated endgame, so we might cut it. But other teams, now that there's ranking points and things like that, the endgame could be important for you because you believe that the endgame is easier to do than to score during the tele-op period. So you have to allocate your resources there. Not all teams do everything, and I don't recommend doing everything either because it's very difficult to package everything into a robot to be able to do it. That's really it. So endgame and autonomous, just keep in charge of the points. So movements and preferences, what we like to do is actually decide all the possible movements that you can do in a game. So when you're doing the brainstorming session, list them all out, whatever it is, as basic as driving around or as complex as scoring a hatch on the top level of the rocket. This way you have a full, entire summary of everything that a robot could possibly do, and then you can pick and choose what you want as your preferences. This could mean that if you want to pick up a hatch from the floor, or if you want to pick it up from the feeder station. Everything should be listed, no movement should be guaranteed out, even if it's simple, because then when you start circling what you want your robot to do, you can separate those into your subsystems. So you know exactly what your intake needs to accomplish versus what your drivetrain needs to accomplish, etc. So try to make sure that you have everything outlined of what a robot could do. And then you pick and choose what you want your robot to do. And that's it for this one. We also actually tried to define different roles. So in case of that chart over there, for 2017 we decided there's 3 kinds of roles, whether you want to be like a ball and a hang robot, so if you want to score the fuel, versus if you want to score the gears and hang, or if you want to do all 3. And we determined from our analysis that hanging is for sure important because it was worth 50 points. And so it's definitely an easy thing to do in order to get that amount. So hanging is actually in all 3 scenarios. It just depends on what categories you wanted to do. Yeah. So we started off as a ball gear hang robot, and then we ended up as a gear hang robot, just because we knew focusing on that kind of made us better at that game. That's kind of what it is.
Last thing to note is this isn't as important as you gain more experience and know what you can and cannot achieve, but categorize things into needs and wants, ideally in a ranking order, just because if anything were to happen later in your season where you realize, oh hey, this mechanism needs some more weight, another mechanism needs to go. You'll have this needs and wants list that you can reference back to, and it will tell you which systems are more important to achieve the most success. And there have been times in the past where we were running out of weight, we had to look back at our list, and that list told us what is the least important thing that it was okay to take away to make the more important things better. Again, we don't usually look at this list, but it's always good to have just in case something goes wrong, especially for newer teams.
All right, and on 1241, go ahead to the next slide. On 1241, we're relatively visual in terms of our ways to decide strategy and stuff like that. So this is a video of one of our mentors actually going through some of the motions in the game, and it taught us some pretty important things. Do you want to play the video? So at this point, we realized that getting the ball from the feeder station is actually really difficult because you miss catching that ball, right? So eventually, we wanted to be this fast when we do the cycles. One of the things we also noticed is, if you noticed here, he picked up the ball from the floor, and so that made us well aware that you need to pick up the balls from the floor to score well. The last thing up there was he had to reach up really high to toss it in, so we knew that our elevator has to go much higher in order to make sure the ball goes out straight. But this is the importance of prototyping and actually seeing the motion of the game. So as funny as that video is, it's actually pretty important in terms of getting. We have another video of him attempting the end game and trying to climb onto the platform. So this was one of the key factors of why we chose not to go on to level 3, because it did take him some time to set up, and then also we realized that it's actually pretty difficult to get up that high. And so but that was one of the methods that other robots did get onto level 3. And so it's really key to know that that was pretty complicated in terms of emotion. And so we decided not to do it, and we decided to be faster at scoring during the teleop game and choose only to go to the level 2 platform. Yeah. So have fun with it. Like, it is an actual build season that has to be fun. So make sure that you do Goonie stuff like this, because we do Goonie stuff like this and come up with some pretty good robots.
Just like disclaimer, we do not necessarily rip our numbers of cycle times and characteristics just from someone being in a box playing the game. I believed him for a second. I just want to make sure that's clear.
Can you just use the box during the game? Like, just throw a guy in the field.
I think so, but you have to check the rules if it's able to meet weight requirements. You're gonna need a light guy to be on your drivetrain.
As long as you paint them silver too, like.
All right. So some of the movements and preferences in terms of the autonomous and endgame. Watch out for these because it could sacrifice your robot design, or it's actually a good thing to watch out for in order to make your robot even better. So as Shaqeeb mentioned before, some of the autonomous routines actually help you get ahead of the game and be that little bit of difference in terms of beating someone in a full game when you know that you score as much in the teleop. So some of the autonomous strategies, like in 2014, 254 had a 3-ball autonomous into the hot goal. Now that's very complicated and difficult to do, but that was the difference. Those little hot goal points were actually how they got ahead in terms of the match. And then so they knew that during the teleop game that they would score just as much as the other team or any other opponent. So this would give them the little extra points to win the World Championship. In 2019, a lot of teams had suction cup climbers at the end, and that allowed them to pair up with teams so they could do a double level 3 climb. So that was something to watch out for. It took up a little bit less space on there. On the platform, but that helped them get that little extra edge in order to climb in the last 5 seconds or something like that and get 12 points and beat the other alliance, because they know that they would score the same during the teleop period. In 2017, one of the things that we did was we actually had just like a little tiny holder for the gear, and so what we did was we actually just backed up into the peg, and our human player held the peg up really high. And so we would score that autonomous gear without any actuations or anything. He would just pull it out the top of our robot. It was literally like just a little piece of C-channel made out of Lexad holding the gear. But that allowed us to be fast enough to actually start cycling around and another team to score 2 more gears, and we would have a 2-gear autonomous or 2-rotor autonomous. And that allowed us to get extra 20 points in order to make it onto Einstein and stuff like that, right? So those little kind of mechanisms that help your robot score could be crucial for doing a better autonomous in there.
Another thing of note is a lot of these examples reference entire robot design, entire subsystems, or something small as just like an extra piece to stick on your robot. Also note that you don't necessarily have to build in these sort of strategies. A lot of times if you're creative with how you decide to move and how you decide to sort of practice different techniques, you can squeeze out some extra points. Like for 12v5, later in our season, we would practice at symbolics displays every now and then. What we noticed is that if we would climb in a certain way, that we could still fit both symbolics and 12v5 on the platform at the same time, and then still squeeze out the same number of points, even though neither teams had to make a whole suction cup mechanism to do so. So just be creative. You don't always need to build something to do these kinds of things. And another keynote is always consider the reward versus time ratio and resource limitation as to when you're deciding whether or not to do these. As Malavya did before, sometimes for us, if we know that we can cycle fast enough, we'll omit the end game because that resource ratio is way too high versus the reward. You were saying?
Something we found out with the kind of motion of the robot to see if that could improve is so long as our gearboxes weren't broken, which they have become, we were able to just ram onto the 2nd level, and that meant we didn't need a whole new mechanism to do any form of climb.
Yep. Like, again, you don't really expect these things originally, but once you see them and then you get creative, like they just kind of pop up and boom, you're able to do more things that you wouldn't have expected.
Okay, so subsystem categories. There are 4 that we usually choose. And the first one is drivetrain, essentially what moves the robot around the field. It has wheels and gearboxes and things like that. The intake, which is used to obtaining the game piece. We categorize it as just obtaining the game piece. It may not be the same mechanism that scores the game piece, but it could be. So sometimes we like to differentiate that. And it's a big decision to know if your intake's going to score your game piece or not, because then it has to travel through your robot in some sort of way, and there has to be more integration involved. The next one is tool, which is essentially the mechanism that scores the game piece. Intake and tool work hand in hand together in order to make sure that the transition of the game piece is proper. And the last one is end game. And so sometimes we may have 2 tools or 2 intakes, depending on the mechanism. Like last year we did because you needed different mechanisms for your ball mechanism or the hatch mechanism, or sometimes you can combine it the same. A lot of teams in California had these rollers that stuck together and they got the hatch mech, but then they also opened up to get the ball. So sometimes those type of integrations you have to watch out for if you choose to do so. and the subsystem categories.
One more thing to note, this PowerPoint will be available for everyone. I believe Mr. Hunter will email blast all the PowerPoints from the presentation today. So don't worry too much about writing everything down that you see here. Unless it helps you remember.
So now we're going to mechanism selections. We'll go through each of the categories, and then there's just some basic tips and tricks that we'll tell you guys so that to watch out for.
Okay, so first one is intake. While there isn't a lot of selection of this, generally speaking, the way to go is always have some powered rolling surface. Just because if you want to achieve the idea of touch and go, which is basically the key defining trait of intake, you'll always need some powered surface touching whatever game object you're interacting with to force it into your robot. Some key tips are oftentimes you'll want to have the linear speed of your rollers or whatever contacting surface is touching your intake to be faster than the top speed of your drivetrain. Reason being, this way, if your driver is driving backwards, they can still intake the ball. So for example, if they're driving forward to grab something and then it's not entirely in the robot before they move back, it will still travel to inside the robot as they're moving back. It sort of drags the game piece along with you. It just comes down to relative velocities. And the other thing, the other thing is when you're dealing with a game piece that you are going to manipulate and either place or shoot, oftentimes you'll want to consider keeping it still inside your robot. So an issue we ran into in our earlier years is if we're dealing with a ball and we want to shoot this ball later, if it's not continually gripped inside a robot, it'll shake around, right? And then before we shoot, in order to have a consistent shot, what will happen is, or consistent placement, what will happen is we'll have to wait until that ball or game piece stops moving before we can place things. And this could be infinitely long if we're playing against defense who continually ram and unram our robot. So keep in mind about the idea of gripping an object. Sometimes it could be like holding a ball in place while you're waiting for it to shoot. And sometimes it could just be tightly gripping a non-ball object before you place it. Otherwise, you'll do a lot of inconsistencies and that just screws up your game a bit.
For shooter mechanisms, this is essentially a way of launching your mechanism or your game piece into the goal. You can have different types of ways to do it. Catapult is one of them, a flywheel, or a piston pneumatic launcher. Each of them have different difficulties. For all of them, just try to keep in mind that you want to use as many sensors as possible. And the other thing to keep in mind is also, if you want to be really fast at scoring something, usually a wheeled approach is the fastest way in order to launch it out. But for last year, some of the wheeled methods were actually slower than just actually pushing it out with a pneumatic cylinder. So they could be the same speed, but sometimes we prefer using a wheeled method in order to make sure that it launches out of your game as fast as possible.
We don't get into heavy details, just for key notes. If you do a catapult, generally speaking, medium difficulty, but medium levels of success. If you're doing a piston/pneumatic launcher, generally speaking, they are the easiest. They're not quite easy because nothing in FRC is really easy. But the flywheel, generally speaking, gets you the highest reward for the highest work put in. You all know what I'm talking about when I say flywheel, right? One more thing you want to keep in mind when you're dealing with something that launches a game object is, do you want to add a turret, and do you want to add the extra development time to do vision tracking? So generally speaking, both of these things just increase your accuracy and save you time, but they also make everything drastically more complicated. For turrets, it's pretty straightforward. Your mechanism turns independently of a robot. It's up to you as to whether you decide that physically turning your drive chassis is too slow for your mechanism, or if you need to be in one orientation for the sake of defense and one orientation for the sake of shooting. Again, always mind your resources. For vision's sake, now with the introduction of Limelight and other like off-board processing products, the trade-off is a little bit different. So you can either spend the intense software development time and proving to make sure it works and have it low cost, or you can put up the money up front and have a drop-and-play solution for vision with very minimal sort of software development. But regardless, it sort of depends on where your team's resources lie, whether it's in time, if you do this ahead of time, or if you're willing to drop the money for make it easy.
For lift mechanisms. They're just different simple bar linkages. So you could have just a one-jointed arm. You could have a 4 or 6 bar, which is helpful in terms of keeping the orientation as you elevate it. Or you can have an elevator itself, which is essentially a carriage that rides on rails, and it's important to just go up and down, or at least in a linear fashion. The keys to this is to, if you want your robot to be a little bit simpler in terms of its motions, then using an elevator is really easy because it's actually going just in one direction. So your loads and stuff on your motors are always constant. But when you have an arm, because it's like swinging out versus coming in and stuff like that, it does take a little bit more time developing the proper controls in order to use it. That's it for elevator. Lift mechanisms.
So, generally speaking, a lot of end games require you to take your robot and move it into a very difficult orientation. This could be climbing a really large step, or in most cases, it's hanging off something or climbing a bar to where your robot's raised to a height that you really don't want it to be. Two general options. You have a winch, which is effectively a gearbox mechanism that pulls on some rope or string that moves other mechanisms, and you have a piston/pneumatic actuation. So the winch, generally speaking, is fairly complicated, but it'll work in higher load situations. So for example, if you're trying to hang off something that's as tall as a rocket, like you were into in 2016, generally speaking, go for a winch because you A, can't find pistons that long, and B, the load requirements are fairly heavy. You wouldn't use a pneumatic system if, say, you're trying to lift another robot alongside you, because then you need a lot of pistons, or really big pistons, which adds weight and time. Pistons and pneumatics, in terms of hanging, are really easy if you want to get a quick set of points and hang off a low height very quickly. So in 2013, at a pyramid of multiple levels, of which you could pick and choose up to which level you climb to. The first level is fairly low. All you really do is get your robot off the ground, kind of. So in that you'll see what if you just had 2 pistons off the top of the robot, hooks, grab, and pick up. One thing you want to note is when it comes to pistons, when they're extended, they're very vulnerable to bending. So make sure you watch that if you expect this mechanism to take loads that bend along its motion or along its axis of motion.
So we're going to quickly go through some just winning designs from the past for different years. Like in 2011, one of the nice ones was 1114 figured out this chokehold strategy of the mini bot race at the end. So they knew that if you were able to get the first and second place in the mini bot race, there was so many points that were racked up for that they had to just put a minimal amount of tubes on the wall in order to score. So they actually designed their robot to do that, to try to be the fastest mini-bot person, but then only be able to score a certain amount on the wall. So these kind of strategies meant that they would try to execute that during the game, and most 90% of the time they would be able to win matches that way. So the end game was really important in that sense. Next one. In 2014, like I mentioned before, the 3-ball hot autonomous was really crucial in terms of getting ahead because teams were very they were pretty close to each other in terms of the teleop scoring. But then the other things to watch out for was like shooting at a high exit point for the ball meant that the trajectory kind of helped it score better. Anybody who scored really low from the ball and like launched it up, it was a harder task to get it more accurate. So shooting from a high goal kind of helped it out. And then that's kind of it for 2014. 2017, the strategy of doing a 4-rotor offense and then just playing defense to stop the other team was really crucial because that was 140 points or so when you get the 4th rotor. And then after that, you could just try to shut down the other opponent from reaching that goal. So that was one of the ones. And then obviously we mentioned before that if you score the balls in autonomous, you could get that little extra edge to beat the other team. So doing a hopper autonomous was nice because then you'd get a whole bunch of balls falling into your robot while you're shooting. And that caused the teams to get an extra KPA bonus or actually just edge out a team when you would do 4 rotors during the teleop game and you would kind of be tied in terms of score. And I think this would be the last one that we cover. In 2018, one of the things was cube scoring on a moving or losing scale was really crucial, because if you didn't make your robot tall enough or able to be reaching up high, once you lose the scale in autonomous, you would never be able to come back. So that's something to watch out in your designs, is like you really had to be very tall in order to score on top of the scale when it's actually a losing scale. The other one was 3 or 4 cubes in autonomous was actually the minimum requirement to make sure that you always have the scale after autonomous. So Cheesy Poofs had like a 4 cube autonomous because they shot it like through themselves and all that kind of stuff. But they knew that if they got that, then they wouldn't have to fight the scale during teleop. So Cheesy Poof's robot actually couldn't reach up that high when they had to score, because they never needed to. So that's one of the trade-offs that they did, was they focused on autonomous and scoring fast in that, and then they sacrificed the ability to score on a very high scale. They won the world championships because they saw that, but if you were able to score 4 cubes or 3 cubes or something and catch up, then Cheesy Poofs would actually have no chance in terms of scoring on a losing scale. So that was one of the ways. It's just like the rest of the world wasn't able to do that consistently as an autonomous, like they did. That's where there's value added in terms of doing like synchronization in terms of your autonomouses. So 2056 and 1241, we did a 3 cube auto depending on which side you're on. 1241 would score a cube quickly, come backwards, and 2056 would score after. So this way you can catch up. And now we're going to move into the mock kickoff, actually. So, yeah, how many people? 36? Okay. So what we'll do is we'll try to get you guys into groups. If you guys want to divide yourselves up into groups of 8, we'll show the game animation video, and then you guys can get into your groups. What we're going to do is just go through some of the rules for this game, things to watch out for. Then we're going to list out a bunch of motions that you guys will shout out as to what a robot can do. And then we'll do some scoring analysis, so you guys can decide what you want your robot to do. So we'll spend a bunch of time there. So if you guys want to divide yourselves out, try to keep the groups to about 6 or 7 people maximum. And then if you want to do that, we'll show the game animation right after. Yeah, so go for it, divide.
Ideally, turn your chairs around so you like make circles.
Yeah, make
Discuss
circles.
face to face.
Make sure you still have a view of the projector. Yeah, try to just turn yourselves around if you're in the front row.
I don't know. I'm kind of scared to socialize.
Sure.
Heavy. Heavy.
Someone joining us.
Yeah, so guys in the front row, just turn around.
Yeah, sure.
It might be easier to just look at it.
We're left. I don't know where we're going. Oh, person.
Yeah.
Okay. Let's try. No one wants to see about the yellow people.
We've only got 3.
Okay, should we do it? Okay.
Yeah, let's go.
Okay.
We'll start the reveal of the game once you're...
Okay, I'm ready.
Okay, sweet.
You good? Strong.
Or is it just an image?
So it's 2016. Stronghold, medieval theme. For those of you who know Copperfield's history, there is no correlation as to why we chose this. But yeah, we'll get to it shortly. So a quick explanation, I guess, is center of the field, there, what you have it?
Okay, that's working. I think the sound's coming from the projector. No, okay, I tried.
Okay.
Welcome to the first robotics competition and the 2016 Tournament Challenge Burst Stronghold. The Alliance quest is to breach the opponent's defenses, known as the Outer Works, weaken their tower with boulders, and capture it. The low bar in position 1 is permanent. defense in position 3 changes periodically by audience selection. Opponents are savvy and will be strategically selecting the remaining 3 defenses to strengthen their outer works while in line for their next match. There are more than 10,000 possible field configurations. Robots start in the neutral zone and may have 1 boulder each. Additional boulders will be placed on the midline and in each castle. Alliances may assign a spy bot to start in their opponent's courtyard and a human player to occupy the spy station to signal intelligence about activities on the far side of the field to their castle. The first 15 seconds of the match, the robots are autonomous and may earn points by reaching their opponent's outer works, crossing defenses, and scoring boulders in goals. During the following 2-minute and 15-second teleoperated period, human drivers remotely control their robots. They retrieve boulders, overcome opponent defenses, and score boulders and goals from their opponent's courtyard. The first time a robot fully crosses a defense, some of the base lights will turn off, indicating that defense's strength is reduced. On the second crossing, all lights turn off, indicating that defense is considered damaged. Once any 4 of the 5 opponent defenses are considered damaged, the outer works are breached and the Alliance receives points. Human players deliver boulders to their secret passage through their castle wall. Alliances may have only 1 robot at a time in their own courtyard to defend their castle. As boulders are scored, the tower loses strength. Once enough boulders are scored in the opponent's tower, the opponent's flag will drop, indicating the tower has been weakened and can now be captured at the end of the match by surrounding it. During the last 20 seconds, robots may extend to reach the tower rungs and scale the tower for additional points. If an alliance captures their opponent's tower at the end of the match, their flag is raised and the alliance earns more points. The alliance with the highest score at the end of the match earns the win. Step into your castle, proudly raise your team's standard, and face the challenge ahead at this year's first robotics competition, First Stronghold.
So this was a very, very complicated game. There's so many things that you could do during it, but we're just going to go over some explanations as to what the video kind of showed. The goal is to breach the opponent's outer works or their defenses, and then to score boulders into the opponent's castle. And there's a high goal, there's a low goal. You get points for that accordingly. And then you can get boulders from 2 locations. One, they started off in the center of the field, and I think there were 8 boulders there, or 6. And then you could also go into your own secret passage, get boulders, and then from the feeder station, and then you could drive back and then score on the castle. Other boulders, like I mentioned, would be on the floor, so if you missed a shot or something like that, you could pick it up, score it that way. And then there are some protected zones. The secret passage, which is just an alleyway in front of your feeder station, was protected. So if your opponent touches you, they get a penalty in that area. And then the other one that you could do is also if you're contacting the outer works. So the defenses had like these 2 ramps and then a lot of different types of obstacles in the way. If you're touching that, then you're also protected. And if a robot touches you, then they get a penalty. Then the end game is the idea to capture the opponent's castle after it has been damaged. So you have to score a minimum amount of balls into the castle in order to weaken its strength. During the actual regional events and district events, it was 8 balls into the castle. Whether it's in the low goal or high goal, it doesn't matter. But then in World Championships, they actually increased that amount to 10 boulders in order to weaken the tower. Now, once it's damaged and you've scored that many balls inside, then all 3 of your robots, all 3 alliance partners had to get onto the platform, or what they call the batter, in order to capture it and get the extra ranking point. So you got 2 ranking points. One is for if you breach 80% or 4 out of 5 of the outer works or their defenses, and the other one is if you capture. So you do score the 8 balls and you get all 3 robots onto the platform. So It's pretty complicated in terms of doing it. And then when you're capturing, you get 5 points to get onto the batter, but 15 points if you climb the rung as well. So there's a lot in this, which is kind of nice because then it'll be a bit more complicated in terms of choosing what you want your robot to do. And then we'll go over some examples.
So 2 things of note, 3 things of note. First is we're sort of speeding up the process. This would have been noted down on like a whiteboard after reading the manual for both those 3 hours we mentioned. Another thing of note is that for both climbing versus sitting on the batter and scoring low and high, they both contribute equally to the corresponding ranking point. So if your goal is to hunt ranking points, know that regardless of whether you choose to score high or low or hang or sit there, you're contributing the same amount as someone who's doing the other thing, and the difference then lies in the point value. This way, people with lower resources can still contribute to gaining ranking points.
So we're going to leave this up here while you guys decide on some of the scoring analysis and the movements. Essentially, there's a map up there of the field, and keep in mind the actual naming convention of everything is kind of complicated. They didn't call it balls, they just called it boulders. The secret passage is over there. So if you're on the starting line on the right-hand side, let's say you are the red alliance, that's what that is. So your secret passage is right beside you. You can get boulders from your feeder station, but then you have to go to the opposite side, across the outer works that's attached to the blue secret passage, and score on the blue castle, on the far end. So it's not like last year where everything is within your half. You actually have to go to the opposite side to score. The point values are up there as well. So in autonomous, if you reach the defense, you get 2 points. If you cross the undamaged defense, then you get 10 points. If you score in a low goal during autonomous, so you crossed the defense, you went into there, you scored a low goal, you get 5 points. If you scored a high goal, you get 10. And then during teleop, those values reduce in terms of point level because it's an easier task. And then at the bottom is actually the challenge, which is if you get onto the batter, it's 5 points per robot, and then 15 points if you climb the rung over a certain height. There's a diagram of the castle over there too. So there are 3 high goals. They're 45 degrees to each other. And then there's 2 low goals on the bottom. There's no low goal in the center batter. And the batter is actually divided into 3 parts. So you can see that it's kind of like a big semicircle around the castle. So yeah, what I want you guys to do is determine.
For that, we should explain how the defenses are grouped.
Oh, yeah.
That's next.
Okay. These are all the different types of defenses that you would be able to cross.
So notice they're split into paired categories. If you see the portcullis, which is the top left, you will not see the cheval, which is the several teeter-totters on the right-hand side in category A. You'll learn to cross one or the other, but you don't really control which ones it is you'll have to be dealing with. And it applies to every single defense. Also, key thing to note is when you're looking at the field manual portion of the game manual, note driver visibility, because that will affect how you decide to do things and how you decide to play the game in teleop, and what you're willing to deal with or not willing to deal with. The only thing that's consistent for every single game is that one of those defenses will be that low one. Everything else is subject to change based off crowd noise and the opposing alliance choices.
So you'll always see 5 different defenses, and each of those options, except for the low bar, can be interchangeable with its pair. So the cheval, or the 2 little teeter-totter ramps, versus the giant doorway that you have to lift. Or, like for example, the one on the bottom, that's called a sally port or a drawbridge. One is you actually have to lift the bridge down, and the other one's just a giant door.
Swing sideways.
Yeah. So you can decide which ones you want to accomplish, and then you can also decide whether you want to score high or low. Do you want to climb up top, or do you want to just stay on the batter? And how many of each is what you guys will determine. So we'll give you guys some time.
We'll go back to the slide so you see the scoring.
And then if you guys ever want to swap between slides, let us know so you guys can see the different objectives. And then what I want you guys to decide within like 20 minutes or so is which height are you going to score the boulder at, if you're gonna score the boulder, and which defenses do you want to cross, and we'll swap the slides if you wanted to, and then whether you wanted to hang on the rung or just stay on the back.
Also, one last thing to note in scoring, the defense points you get are finite because after you cross a single defense twice, you no longer get points for it. The only thing that will happen over and over again is the ball scoring because that's recycled. That's it. Go ahead.
Yes, so you guys have 20 minutes to.
I feel like it would be most.
It's a really complicated.
Go for the bottom tower. It would probably take the least amount of time to actually get lined up, throw it in, and we could just get really good, really snappy.
One thing I was gonna say was like, I was told that like because it's happened before. Something people did was like since that one defense is the one that everyone has to do, everyone wants to make the robot like quickly do it. I don't think we can do that. Like we're also gonna be something everyone else we want to actually make any other money.
Yeah, I was thinking we should go over the category D ones instead of the
Category category D
the category D was the really low bar and then the top.
Yeah. So like the rocks, the moats, the little wall.
So they didn't seem to be that far, so it might not be that hard to just drive over them with a good drive speed.
I think maybe like I wrote down it was really important to go and conquer the defenses during autonomous. So in order to conquer as many of them as possible during autonomous, because it's 10 points, which is as much as a high ball, which is harder to do than cross over the defenses, right? So I suggest maybe like on the base, so you could usually go over, come back, shift over to the next one, over and back. So that would be like 10 points, 20 points, possibly 30 points just from sections of autonomous.
Okay, so
If you're fast enough.
how would we deal with like category E though? As long as you're large
I don't think you should focus on listing that because other teams will lift it up for you. You could go through because obviously that's a task that people need to tackle. They don't want to be the one who's going to do it. Someone else is going to do it.
Both of those, breaching is an end of game condition.
He wasn't there for Stockholm.
Darn, I thought you were there for Stockholm.
I know RC very well, but I don't think that would work because like it would take a fraction of a second off, but you also couldn't like get the height.
What do you think
Bigger
in an ideal case, if you
Shut your face.
assuming you win because
I'm
you're
sorry.
and an extra
So at tank base, that's getting as many defenses as possible on the
you're going to naturally
is, I think, priority one.
should we get back up and
this game is special because you get balls just by playing because we want
Also,
There are
topic sense a lot like you've been saying. It's like well, I'm saying.
What's the difference in points between those?
So keep those in mind. So try to find out ways that you can do it.
So we want to cross all of these things.
Golden high goals, 5 for Teleop and 2 for
Highest
Moat.
score
But the thing is, like, sure, we could do the high, but if we can do the low one quicker, we can make up for the point.
Two low goals in the time that it takes
If we mess up the high, then we have to get the thing
That
back.
is the thing,
The
'cause
low
I
one,
don't-
you can't
I
really
think
mess up.
None of us were here when that was the game was played, but I remember like I've seen like I've watched some games before. When you like miss the high goal,
yeah, that's
it's got hit.
okay. I agree.
Are you able to hold multiple?
You weren't allowed to extend beyond
Definitely not.
even less.
And I think it's also important to fund and get the, what was it called? Get the capture.
Some last it's like ending period.
Capturing is a ranking point in qualifications, which is definitely something you're going to have. And then in eliminations, it's 25, so that's the biggest amount of action. The biggest action that you can get for points. So I think that's
That comes with the thing, like when I said we don't have to make it low to do that one certain defense, we could make it higher, so the mechanism for time is a lot easier. So like you don't have to have ways to extend 20 points. You know, it's not 20 points. You know,
Ranking points so much.
On that one category C, that's just still balanced to just run into that.
It's a flat.
It's a flat.
Which one? On the
I
left?
think it's the low one.
So
Do you run into it or do you have to pull it towards
These things are interrelated.
You just run into it, like it goes over.
Does it go both ways?
It's like, yes, it does go both ways. It's like a curtain. It's just a hanging piece of fabric with a metal
Then
bar.
why would that?
But it's low.
Okay.
So like, you know, so
We were talking about. I don't think it's the same what you're talking about.
We're talking about.
Think about
That sounds. Are you
I think he's talking. I think you're talking about like. I think you're talking about like the one that's really low that you have to like just.
well, like the one that's in like the what is it called? The thing with the squares at the top. What are the things with the squares at the top? The wall, the caption gate. You know when they replaced out the bars, right? And they just had a thing at the bottom.
Yeah.
That's
Yeah.
the same thing as the low one.
I don't know if that's true.
Swap mechanisms right before that.
most teams don't distance based on just our
That would be hard.
Oh,
You can easily, but like that's a more.
probably not? Because your mechanisms would have to be.
Hot swappable.
Yeah, and they're.
I think that's more like a low.
I mean, then again, you can think about buffers.
click it in.
Like,
Yeah.
I mean, you hot swap bumpers
Like-
now it's fine, but it's also limited.
I don't know if that's.
I don't know if that's
Yeah.
You guys have questions?
Alright, could we switch to the side? Sure. One more time? Yeah. I feel like that's
And also, how does the category C one on the left?
But also know that you likely want to decide to travel something else.
We haven't actually talked about how. Okay, we'll not talk about that first. First of all, like yeah.
For the sake of
So the first one is are you talking about category C?
Can we see the one on the
On
left?
the left side?
Yeah.
Okay, so it's a big drawbridge. It's about this high or so. And it's just a big piece of accent that you actually pull.
Oh.
Yeah, you have to pull it down and then there's springs when you let go, it'll snap back.
you can't push it down.
No, you don't push it down. Yeah, you actually pull it towards
Do you have to push it down on the way back through?
No. So you cross it where you have to pull it down and go over. You can certainly go over one defense, come back, then push it down from one side and help your partner get over it. But the idea is you have to be able to let go of the defense
leave
and then
double check the Malavya.
catch it and
The
then
middle will only be a specific category. So in the
so
middle.
one of the things that the Sally put was just this giant door, right? So some teams went through and then came around. They pushed the door open, spun around in a circle, and then went through again while the door was still open. So you can keep that in mind. That's one of the things.
Okay, so hold on. So like, if we're talking about like going over two defenses in auto, that could be like. Go over turn around, open the door for ourselves.
They could be in it.
Just keep in mind the only thing that was constant is the position of the low bar. It's on the very outer edges of the field, but the other four spots could be switched with any defense.
Even if we can just accomplish 3 out of the 5, that would be really good. So we can easily go over the thing. The low bar would be easy. We didn't want to focus on it, but it would be easy. What else would be easy?
I think it should just be so like you know the one that has like the multiple kind of
Yeah,
wood
the
panels.
teeter totter.
I think we should be able to do the teeter totter for part of A. So that conquers like half of A. But ignore the entire section
So,
of
for the sake of
the
moving
low
discussion
flap
forward,
and
what
the
if you
pull
decide
down.
to-
I don't think
what
we
if you
can
locked
do
in?
that.
Like,
And then B and C.
Those
would be
those things could just be like both of those things though could just be like conquered by someone on the other side pushing.
Yeah, exactly. So,
I don't think we need to commit a mechanism to that.
and you can already go over most of the defensive progress. So
So how can we accomplish the 5?
Yeah, that's
decline, grappling hook.
okay.
No, think about it, like pneumatic shooting, and then grappling, and then like you know in roller coasters with like the gears and stuff, right? That pull you up to like the top.
So kind of a raptor lock
It's like kind of a wedge
Which
type
is
thing.
fine if that's like with that's the.
I don't understand.
So like you know how grappling hooks work.
I don't think it should be something like we're shooting at it. It doesn't seem like a good idea.
Which is fine. It's just for a strategy thing.
Yeah, I feel like that isn't
Would you
the
just
best.
take the part, so like the fire hook part at the end?
Yeah. You need to cross four times.
I I feel like that's not a good idea though, because if you miss, now that's dangling around and you can't.
No, but then it's bad. Would you have to make it back up?
One of which would be different. But the requires which may or may not be worth it for you guys. So I'd like that you've dialed in the categories you want to choose. Have you decided
Yeah,
to
see,
choose
that
would be the problem.
So maybe we should make
So I
like a
guess
small
I could put this on your
elevator
roll.
to actually pull
Yeah,
us.
because if we do that, like, if we don't really want to focus too much on that low bar, we could just make it an elevator. Because that's the one thing. Like, it's harder to climb when you have to make the robot so low.
Yeah. And if we've already got an elevator, then we can easily lift the gate.
I think maybe reaching defense as an auto would be because that cuts a lot of points. And then
Climbing would be number 2.
So if I may ask, what have you guys locked in so far?
We have locked in that we want to be able to accomplish going over as many defenses as we can in auto. We're going for the low on the castle, and we want to climb it.
So you're going to do every single defense.
Well, not every, like,
Just as many
So
as
be specific. Tell me which ones you don't want to do.
Like, one thing
that can be accomplished from the other side, so like the drawbridge and swing, we don't want to touch those because you can just go
So you're
from
not doing category C.
no, not category C and not the gate.
Although we
Category
could do category
well, like, I mean, no, we could do the game. Well, hold on a second. We haven't decided that yet. Like, one thing we didn't want to make our robot super low, so I conquered the low bar, because we feel like that's something that almost like all teams are going to try to do. Like,
Which they did.
which they did.
category to category.
You don't want to sacrifice the climb.
Yeah, so then like it would be easier to make a better climb mechanism if we don't have to be so low to the ground.
Okay. Have you dialed in low as high? Sorry, I missed that. You said low, right?
We thought low, we haven't thought of what mechanism that would be in.
Because other teams will try and shoot the top, and we can use our balls so we can lower the defenses for the towers.
I haven't seen many matches, but we were thinking we could do both category B, both category D, and use the gate one way, just with the good driver.
Okay, so I'm going to double check if you can both ways crossing counts. Because I think they did it only going from the neutral zone through counted. I'll double check that for you real quick. But to note down, you decide category B for sure, B for sure, and maybe C. Sorry, no C, no C.
Well, like, so no C, but out of the,
again,
so like, but that could just be used to assist another
so
robot.
assuming that's, let's assume, looking at the solo possibilities and assuming that you can only go one way, just for worst case, you can only contribute half of that ranking points worth of tasks, which isn't necessarily a problem. Again, stick within your resources, just know your scoring limitations and stick with strategic analysis later.
Would we be able to drive over, say, defense D, drive back, and then drive over again? Would that count as both?
Yeah, as long as going from neutral out, as many times as you'd like. You can people do that twice. Like they'll go, come back, and they'll go again.
So like,
If you win
Give me 1 second.
so
you have on
that's basically
Stop.
no, but no, listen. So like, we have fast omnis, right? And there's like a category D beside each other and a category D beside each other, right? You would drive over category D, go back, drive over, come back, then just shift, and then do that again. And then we get the automatically 40 points, which is a lot.
Counterpoint.
So it is only one way crossing that counts.
Okay, yeah.
The hard way
Yeah,
crossing.
yeah, that's fine. Okay, counterpoint. Omnis, I don't think we could actually get over something. Like with pneumatic wheels, we can really just drive over top. Omnis, like, if we really try, we're gonna break the omnis. And that's a bad idea.
What is pneumatic? Pneumatic wheels are just tank, right?
Like, we use, those are the ones we used. Tank is a drag, that's something.
The pneumatic wheels are like the rubber tires.
They're like, it's like car tires, but small.
Oh, okay.
That's what we had.
Sorry, I haven't. This is my first time on the road.
Hey, you're the man with the
I don't know for sure, but I don't think auto for this game to be I just not a fun time.
A lot of the things
I haven't done an auto.
10,000 configurations too.
I haven't done an auto, but what I would think for the actual programming side is having where you can just on a screen before the match select this is where each one is, and then it will automatically determine.
That is a thing that we could do with the programming. Okay, as long as that's a thing we could do, like I feel like
It wouldn't be too hard to do.
okay.
Well, I mean, like, if you had like a sensor that just sensed whether there was like a wall or not, so, like you have it a certain height above the other ones, and if it was clear, you could just go over and come back. But like, let's say category C, the sensor hits like the flat.
Yeah,
or
but say if that's happening, we could easily have a problem where a robot's going through the low bar and our robot's like, hey, there's nothing
Actually,
here.
the defensive right there.
That would be true.
I think
Well, I mean,
you
you
would,
get a robot.
At the end of the game, once all the defense
in some cases are good, but I do think you definitely need to just tell the robot
Where everything is.
Yeah.
Sometimes you should.
Yeah. I feel like sensors should be used more for like aiming and like
And quick pickup.
things like that. Which, okay, that's something we haven't actually thought of. Ground pickup. Is that a thing we should do?
Yeah,
probably.
That's the only
Oh yeah, right. Forgot that was a thing. Okay, my head is in deep space. So,
So I think, would we be able to like have our robot kind of almost split in the middle so we can just run in, grab the ball, and then just run
can I use
out?
paper?
You're saying the
Well,
mode
can I use paper?
outtake would be separated.
What?
Yeah.
Actually, no, never mind.
Straight through.
Okay, hold on. My thought was like, what if we just, like, if we're just doing low goals, why can't we just like do something as simple as like on one side of the robot we can have her climb, it could be fine. And on one side, literally just wheel intake, and then reverse the wheel machine on.
Yeah.
Then the other thing is that would take up way less room, especially if we want an elevator. Yeah. But it, I mean, we're not good enough to actually have this effect whether we win games or not. But for some teams, having to spin around, like having to go, stop, spin, go, would be a lot worse than just go.
Oh yeah, especially with like pneumatic wheels, the turning is really bad.
Yeah, it bounces quite a bit. So
But, like,
maybe we should just like split it down the middle so we pick up and then shoot it out the other way.
That might be better, but at the same time, where would we put it elevator?
That's true.
It would have to be on both sides maybe, or one
So
side.
guys, just listen up for a second.
Split it.
There's about 7 more minutes for your decision making and stuff like that, and then actually, sorry, 3 minutes. And then what we'll do is just keep in mind that in these defenses, you have to cross them as if you're going from the bottom left corner to the top right. So you don't, like for category C, you have to pull down the drawbridge and cross through that way. You have to pull the sally port open and then cross through. You don't get points for coming back.
Yeah, one-way crossing only, and it's the hard way.
Yeah. And then, yeah, just keep in mind. 3 minutes, and then we'll ask each group what they want.
You know what? What if we ditch the pneumatic wheels and just use like slightly wider ones so they can get better grip, and then at the front put kind of a wedge so that we run at it and it just pushes us.
Oh yeah, we literally, yes.
We have like a nylon wedge that we just kind of.
And then it would ramp us over. That would accomplish both category B and D, and it would let us do our everything.
Because we're still not using this
Yeah, terrible.
Yeah.
Okay, sorry. What if we had pneumatic omni wheels?
It's not a thing.
We could make it.
Wait, the mini sideways
Have you seen people with the like the 8-wheel drivetrains with 4 wheels, where they've got 1, 1, 1, 1?
Can we just do like 8-wheel drive, like trying to find?
I don't think they have one.
Okay, I don't know.
They have an omni
I mean, like that one does use 8 wheels, but they have 2 omnis on it. So.
Yeah.
Wait, so 10 altogether or 8 altogether?
Let's go 6.
6?
Like, is it 6 regular ones plus 2 on these?
6? No, we don't want any on this.
No,
What? No, we're talking about.
Wait, we're
Oh,
being
I'm talking about that one. That one has.
Are we just doing 6 wheels, 6 normal wheels?
We don't really have time.
Not nylon tread. Or yeah, wait, are they?
a wedge up front.
Whatever the normal ones are.
Whatever gets us better
You don't know
grip.
what a wedge is? A
triangle
wedge
shape.
is.
Well, I know the wedge. I know the wedge is on the wheel.
It's a way to cook potatoes. What?
On the wheel. Like on the wheel.
No, the wheel doesn't have anything to do with it. Just like literally on the front of the robot, just
Put a wedge?
that shape.
So this is our drive chassis.
Okay.
Wheel, wedge.
It's literally like the shape
So
of like a boat.
We get
So, like, it
momentum
just
and the
goes
wedge,
up.
if this is an obstacle, we get momentum and we just get height from that.
Oh. It's like we are the ramp.
Yeah.
With wedge, so you know.
Not necessarily.
Well, so
Yeah,
we can
not the back.
Oh, actually,
Yeah.
good point. The back, if you want the ball to go through the robot, then the back might actually be there, so then we can avoid.
And so we can do it.
Alright guys, we're gonna start. So,
Here we go.
Pencils
Okay.
down, I guess.
Elevator.
yeah.
Wheels and
Yeah, yeah, yeah.
And then I'll just go through group 1 through 5.
On some of the time.
Yeah, that's
Sorry,
not,
guys?
since we have the new wheels, it would be.
Oh, we're going? Are you going up?
It goes up.
No, I mean like where would you start?
That was funny.
So like stop
Oh,
discussion.
sorry.
Also, one key thing is
Yeah, no, that was
generally speaking, during Saturday, which is just tonight, try to avoid discussing drawings at all. From the idea, you draw from experience in terms of like realism, but try not to avoid.
Alright guys, so we're gonna see what all groups have decided. We have 5 groups. I'll just write them on the board and we'll see the variations of everything. I'll go through group 1 and then through 5. And then we'll show you guys some strategies that were done during the season and just a couple of match videos so you can see how complex or how simple robots were during that season. So group 1 over there, what did you guys decide as your boulder scoring?
We pitched two different ideas. 'Cause
Sure.
we had two different like kind of designs.
Okay.
So our first one was we couldn't really find it in our team that it was feasible to do high scoring and the low bar.
Okay.
So we wanted to go for high scoring
Yeah.
and then get most of the defenses. We found that category B and D could be done in the drivetrain,
Okay.
and then A and C could have been done with just kind of like an arm type of motion,
Okay.
and then also be able to climb.
The rung, like
Yeah.
up all the way? Okay. I'm just gonna write on high. Okay, what was your second?
Yeah, so we took a look at doing only traps and low boulder scoring.
Okay.
So we, like they said, we'd use a pneumatic tires to help us over category B and D.
Okay.
And we have a small stowable arm in a robot that could lift up and manipulate categories A and C.
Okay.
Our whole profile would be small enough to go to the low bar.
Okay.
We can pick up and move around some of the boulders, but only to the low goal,
Okay.
and we would not climb.
Not cool. Okay. Okay, group number 2.
Okay, ours is similar to their idea where we're gonna make a low one that can make it through low bar.
Okay.
And then we're gonna make really simple elevators so that we can completely ignore category C.
Okay.
And just do A, B, and D.
Okay.
And then our elevator is gonna have a shooter that can shoot through the wall.
Local? Okay. And are you gonna climb or no?
No.
No? Okay, group number 3?
Actually, before we do that, just one thing to note, I don't believe that you could extend to height unless you're hanging.
It's okay.
Wait, I think that's not correct.
Ben.
1678 did that.
What, extend?
Like they
They were still under height limit.
Oh, you mean like the height limit of the starting configurations?
Yeah.
Okay, yeah, then no, you're right. Yeah.
Okay, sorry, go ahead, group number 3?
Okay. So our main idea at first was that we thought like many other teams would go through like the low bar and make it lower, so less room to make other mechanisms. So we didn't want to do that.
Okay.
So we at first wanted to make a taller robot so that, not taller, but we wanted to have room for an elevator to do a high level climb in the end game.
Okay.
So that would be one part of our robot.
Okay.
And we would also want to score a low goal and have another mechanism on the opposite side of the robot.
Okay.
That would just be like simple, like 2-wheel intake, and then opposite for shooting out.
Okay.
And one thing we thought, we were going to do pneumatic wheels just to get over category D and B really easily.
Okay.
But we then thought that we shouldn't, because since we have the 2 different mechanisms on either side, we realized that with pneumatic wheels it's kind of hard to turn around. Like spinning really efficiently isn't easy, so we're using just like simple, like I can't think of what the wheels are called, just like sort of kit
The
wheels.
traction wheels?
Yeah, traction wheels.
So which defenses are you gonna cross?
Yeah, so we still, like, okay, well, yeah, we could, with the elevator, we could also lift the bridge with A. same mechanism we're using to climb.
Yeah.
And we still want to do B and D, so we thought by making like the front of our robot like have a wedge on it, we could even if we didn't have the pneumatic wheels, we could drive up it and it would be like its own ramp
Nice.
to get over top.
Okay.
And so
And then
yeah,
did you want to do category C?
yeah. We didn't really want to focus on that.
Okay,
So.
that's good. Alright, number 4. Yeah.
So basically, that group number 1 second thing.
Okay.
That's basically exactly it.
Okay.
Except, we thought that it would be that given that plan that we could do a 2-ball autonomous mode.
Okay.
Anything else? Yeah, that was it.
Cool. Okay. Alright, group number 5.
Yeah. Yeah. We had a plan.
He's alumni.
You wanna do it?
I'm alumni, I should not be doing this.
Okay, so we gotta do it now.
Okay. We were gonna do high score. We're gonna be able to go under the low bar,
Okay.
do categories B and D, maybe by having ramps and ramming over it,
Yeah.
and not climbing.
Okay.
And basically pick up from low and shoot high.
And would you do category A or C?
No.
No?
Well, if we, maybe, like we might put an arm on, be able to put an arm on it if we could fit it in there.
Okay.
But it might be hard because you're picking up low and you gotta shoot the ball out of the top of the robot, right?
I love that the 75 lines came up with
Cool.
just ramming the
Okay.
defenses.
So I like this. There's a lot of variations, which is really cool because this one, I think it was Code Orange that did that, and they were like finalists inside. Actually, they were on Einstein. This one here was regional winners, actually, as third robot, because they would be defense and then they would do all of these two. And I think this was 118 just without the climb.
Yeah.
Yeah. This one here for low score, BD&A is low climb. That was regional winners. This one here with low score, BD and high climb, they're usually the team that would actually rank first at regionals, which is really cool. This one here with the 2-ball auto, low score, that's actually like just a better version of this guy, so that's cool. And then, but you did sacrifice the climb, which is valuable, and it actually pays off if you do sacrifice the climb for that. And then this one is also similar to this low climb one, except you just have the low bar as well, which is cool. So a lot of these variations were actually robots that were really successful, and they did a certain amount of rolls and certain amount of points in order to make an alliance win. So we're gonna go through some of the other situations that could do. So this was just a list of motions of everything that you could possibly do. But here's where, this was one of the strategic goals that 2056 picked. So what they did was, they wanted to cross defense A, B, D, and the low bar. They didn't want to do the category C because it's really tall and big. They wanted to traverse the secret passage, so they wanted to get boulders from there. Score in high goal, and then I just have some of the categories of points there. And then they wanted to do it from the outer works in the courtyard and also close to the castle. So they actually had different variations in terms of their shooter. They had a little hood that popped in and out depending on where they are in the field. And then they wanted to score in low goal, which I don't think they did, actually. No. They wanted to camera track. They wanted to get the boulder from the floor, so they had an intake. And then they wanted to climb onto the ramp. Now, a lot of these are really good things, but imagine packaging a high climber with a robot that can do all the defenses except for the big one, and also be able to score in the high goal. It's very complicated, and it's actually really hard to package all that because you have to get through I think it was a 14-inch window for height. and the rung is like 8 feet up in the air to reach up to climb. So it's actually really hard to package all that. Now, another strategy was actually our 1241 strategy, which was we said no to the low bar, but we'll do all the other defenses. So we're able to do category C and stuff like that because we realized that in order to get the low bar and climb high, that's, I think, a 20-point difference because you can cross the low bar twice and then you climb, which gets you an extra 10 points versus the 5 on the batter, so 20-point difference. We'd make up for it because we'd do category C, so 10 points are gone there, and then we would score 2 extra boulders compared to other teams because we didn't have to try to fold ourselves into a smaller package in order to do it. So you could sacrifice having a high hang and scoring extra boulders versus going under the low bar and having a high hang. So that's some of the analysis that you guys have to picture is both teams were successful, both teams won regionals, one team almost won world championships, but there was this dumb rules about ties during this one. But yeah, so there was the final match of the entire world championships, finals match 3 was a tie between the 2 alliances, and the tiebreaker was which team had the least amount of penalties. It wasn't like a replay, it was actually just amount of penalties. So 2056's alliance had 5 points of penalties, 1 penalty, and the other team had 0. And say they lost world championships because they made this dumb rule that tiebreakers will be cut away by who has the least amount of penalties.
That's painful.
Yeah, yeah. It was like 214 to 214 or something like that in terms of points. Really stupid. So they took that rule away the next year. They had something else. Yeah. Okay. So remember that when you guys do define what your robot is doing, that you separate it into these 4 categories so you know exactly what the intake has to do. If the intake is supposed to help you cross over category C or category A, category B, whatever it is, then keep that in mind when you're brainstorming about it, because then you'll say, I need to make an intake that is able to do that. Yeah, so some winning designs in 2016. There was 1241, who was a tall robot with a turret. So we chose a turret because we wanted to be more accurate that way.
We did turret and vision. We didn't think one was worth it without the other.
Yeah. Then there were some teams that actually did the outerward shot. So they shot from the defenses. So they cross over, really quickly shoot, and then just cross back.
That's about the distance between here and that rocket.
Yeah. So it's about 1/3 of the field, right? So they were able to shoot that far. Other teams had something called a hanging shot. So they actually turned their shooter around, and when they climbed up at the top, they actually shot into the goal. So this is a last second shot, 5 points, could be the difference between a win and a loss.
See, because it's 6'10", it was great.
It works that too.
Yeah. Okay, so here's some videos of some really cool robots. I'm just going to go through there. So this is actually going to be,
Steve, right?
yeah, this is going to be Team Dave, which was really successful because they won a regional and they ranked 2nd at World Championships in their division. If I can get this to work.
I believe they went with this kind of strategy. So low scoring hang. They did the low bar and 3 other targeted defenses.
And here we go.
Okay, so watch out for this robot here.
3 robots crossing the defenses. Blue Alliance, 3 robots crossing the defenses. No shots on goal yet. Martian shoots, scores. Engineers shoot, scores. And with that, we're going to be 40 points all as we go into 2 minute, 15 second tally-up. Drivers at the controls. 3-4-1. Miss Daisy scores right away. Blue Alliance answers with 2 shots of their own. 10 points for 7 points.
So it's really hard getting around all the defenses. This is why they're going to go over category A, which you have to put the ramp down and then cross over. And then they'll quickly score a low goal. And then right there they just shoot it up. Then they'll start going back out again, try to get a ball, and then they got the ball, and then now they're just going to score.
Elm City Robo Squad shot just off the mark. Martians.
So now they have to decide how to put back again.
Blue Alliance Tower Strength already at 2. 2 boulders away.
And then if you notice their alliance partner, that really tall robot, that one was able to score on high goals and cross the defenses and things like that, but they shot from the outer ones. So they were pretty far from the tower.
They have breached the outer works. Red Alliance.
And then I think I'll just skip ahead of that.
2502, crossing the rock wall, damaging the defense in the process. 3 defenses down. Red Alliance Tower Strength at 1. Talent trying to make it weaken themselves. It's up. It's in. Both alliances can capture at the end of the round. Here come the last 20 seconds. How many scaling robots will we have? Talent Robotics starting their scale.
So if you notice, they did that defense by backing up, spinning it a little bit, getting contact away from it, and then crossing over. But then now they're going to try to climb high.
They just had a long arm that just went.
One Dave Smile in the last second. We got 2 scaling robots on red, none on blue. Official scores coming up in just a moment.
It's a really cool robot. Okay, now I'll show you guys the most complex robot that was done in the world. Pretty much ever. But watch out for this guy. So this is a team out of California. Alright. So some person said 2-ball autonomous. So they'll do 2-ball autonomous. And through the low bar. So this entire contraption transforms itself and closes in. And then they shoot again. And then now they're going to start playing the game. They did choose category C, so they can't do category C to bring down the entire drawbridge or the sally port, but they do actually shoot from the outer works and unfold themselves and then like contract themselves back in. And alright, so watch it again. They kind of zoom in, which is really cool. And then they shoot it. And they had vision tracking. They didn't have a turret, so they would actually turn the drivetrain and then do it that way. But then it was really cool in terms of how they had this entire flippy thing.
They burned that one.
Okay, we're gonna skip ahead a bit.
But look at the bumper. You can see
Okay, this is them just like stealing balls. Okay, and this is their end game.
What? Y'all didn't know what I got, did you?
Stick or something that you push up instead.
Yeah, so it was like the craziest folding contraption in terms of scoring the game. But they did a lot of the game, but they still sacrificed the category C of defenses. They couldn't do that. So I don't think any team actually was able to do all of the defenses.
I hope whoever designed that robot's working at NASA now.
They are. Yeah. They're actually sponsored by NASA and Google and Apple. Yeah.
971 robots this year. Sponsored by Enbridge Gas.
Yes. For any of the kids that haven't seen 971 robots, because we never see it, it is one of the most unique robots that was built this year. It's like phenomenal. Go look at it on YouTube.
So some pretty cool ideas. This is actually finals match 3 of Waterloo Regional, where you get to see all the different types of robots that you've listed here, like actually all the different types.
And the small one.
Yeah.
Is that Karthik?
Sorry, we'll skip ahead from Karthik's intro because he went like really crazy on this. Okay. Alright, so over there it's 2056 on the far end and Symbiotics. It's 1241 on this end.
Decided from like June, 76 points always got always
So So 2056 didn't have a turret, which is really cool because their drivetrain was really slick. And I know somebody mentioned that using pneumatic wheels kind of makes you jitter around. Our team actually used Gorilla Tape on the front and the back wheels in order to make them more slippery in order to turn, so that we had smoother turning. But those are some of the things to watch out for. It's like, even though you want the pneumatics to take all the shock, sometimes you have to do some really Home Depot fixes in order to make it work better. And we actually had a system as to when to change the tape. I think it was 4.5 matches, and then we had to actually take it to the practice field, get the driver used to it, and then put it back onto clean. Right? So things for fixes. Now pay close attention to 1241 in the center. This is how we did the Sally port. We actually had an arm that went in, opened the door, and then we drove backwards through it. So it was a really complex method of doing it. And we had hooks on there so that if we had to do the drawbridge, we would just pull the drawbridge down. But 2056 and the 1114 both had really good packaging for their endgame mechanism. So they had these big arms that like flipped out and stuff like that in order to hang up. Yeah, so it's flipping. I'll skip ahead to the endgame. Okay, so now pay attention to symbiotics on the bottom right. They have this cool flipping mechanism. And so they had these arms that pull up and then they actually go like that. In order to hang.
Also, if you notice in the bottom left, you'll saw 610 hang shot.
So after all that, what do you guys think the score was at the end of the match?
160?
160?
214.
214? Okay. Any other ideas? 210. Okay. So 1241 and 610 were able to get 210, and 1114 and 2056 were able to get 200. Ooh. It was a 10-point match for finals match 3, which, if you consider it, think about it this way. It could actually be the difference between hanging at the end of a match or not, whether you're on the batter or whether you're up there. It could mean that you've crossed the defense in autonomous versus not. Or it could actually mean getting a hang shot at the end as a 5-point difference versus not. So a lot of these sacrifices, they're all 6 different robots on the field, but each of them add up just a little bit. So if you can optimize what you choose to do, you will be able to win the match. So it's really cool that way. In that, I kid you not, our strategy before going into that finals match 3, we had our 3rd robot that couldn't cross over a defense because the drivetrain wasn't robust. But what we did was we put them in front of the moat and we said just risk it. Because it's final match 3, we have to cross it over. So they crossed over the moat and got over. We got a 10 extra points, and that was the difference at the end of the match. Right? Like the scoring was exactly the same throughout the whole thing. It's just like little things here and there. If 2056 had half a second more, they would have climbed up and locked their robot into place, but they couldn't do that, and then they started going down at the buzzer. So if they did that, they would have won the match. Yeah. So it's crazy how FRC games work, where like little things can make the difference, but just make sure you optimize what you want to do in order to make sure that that's the best that it can be at that moment. Yeah. I think that concludes the presentation. So if you guys have any questions, please let us know.
You have to go to the bottom of anything else?
Yeah.
We're going to plug this up.
Yeah, these are the emails. Obviously this PowerPoint will be available to you after the presentation and everything like that. And if you guys are interested, we are hosting an event called Girls in STEM Olympics, which we've done for the past 2 years. This time it's happening on December 7th. It's at the Scotiabank Digital Factory. And so all girls are invited. And we have solo challenges and also team challenges. And it's an entire Olympics with prizes and different point values and stuff like that. So keep an eye on that. That's it, really. Thank you guys for attending.